For dear students, now we will see what do we mean by an eye pattern. Now to study eye pattern, it is important to know what was your signal transmitted in a baseband transmission for binary data and what was the signal received in the same baseband or transmission for the binary data. So as an example, I have shown over here binary data as 101101 and the waveform for it is shown as plus voltage for logic 1, minus voltage for logic 0, plus voltage for 1, plus voltage for 1, minus voltage for 0, plus voltage for 1. Now this was sent by the transmit filter in the baseband transmission diagram through the channel to the receiver. Now while it was received, it was affected by noise and also there was ISI effect. Now here if you see the received signal, this is for logic 1, logic 0, logic 1, logic 1, logic 0 and logic 1. Now this signal, if you apply to a CRO, y-axis of the CRO, that is y deflection plates of CRO, and to the x deflection plates if you give a sawtooth wave which is of the same signaling rate, which is having time period of TB as you have shown for the transmitted and the received signal, then we will get something like this on the CRO screen. Now this is a waveform on a single signaling rate, that is single time period. That means whatever we have received, see this is the first waveform. First waveform is put on the single rate. Second waveform is put on a single time period. Third is put on the single time period. Fourth is put, all are superimposed on one another on a single time period. Now this looks like an human eye. So it is called as an eye pattern which is seen on the CRO screen. And this eye pattern will help you to study the noise and ISI effect for the received signal in a baseband transmission. And now we will study the interpretation of eye pattern what we had seen earlier. We had got the eye pattern by giving the received signal to the vertical point of an CRO, and to the horizontal deflection plates we used to give the sawtooth wave, and in that case we got the eye pattern on the screen of the CRO, which was giving all the pulses on a single interval time, and that we can study like this. This is called as interpretation of eye pattern. Now here you can see these 2 points, whatever I have marked is the sampling time interval. This is the exact sampling time interval over which a particular sample can be shown. This is center point, which is the best sampling time. This is distortion at sampling time. If it is amplitude is not going on top or less, that also you can see here. This is margin over noise, whether the amplitude is exactly towards to give you logic 1 or whether it is below that threshold, that margin noise you can study. Here you can study distortion of 0. It is not crossing the 0 line exactly at the sampling time. And this you can study as slope to which will give you sensitivity to timing error. Now here, if the eye is open, when it is open widest, you can study what is distortion at sampling time and you can study margin over noise. When the eye is closed, you can study the slope, which will give you sensitivity to timing error. That means whether the eye is open or closed, you are able to practically study how the received wave is, whether it is affected by ISI and noise or not. That you can study in this interpretation of eye pattern. So eye pattern is a practical way to study the ISI and noise in the received signal of a baseband transmission.